Today, what we're going to be doing is something called verifying trig identities. And what that entails is using the skills that we practiced the previous 2 days, factoring trig expressions, using that identity sheet to transform, like sine squared plus cosine squared, transform that to 1, and using some of those other identities from that sheet that we have. We're going to be using those to prove identities. So difference of squares we're going to be using, sum and difference of cubes at times. So all of those factoring patterns will come back, adding fractions, multiplying the top and bottom by the conjugate of the bottom. Those are all skills that we're going to be using to prove trig identities. So our task is to show that one side of the identity is equal to the other. You will only work on one side of the identity. So we can't work on both sides of it, and the reason for that is because if you make a mathematical error, then you may prove the identity be true, but not really do it the right way because you made a mathematical error because you're working on both sides. If you're only working on one side, then if you make a mathematical error, you're going to know you made that error because you're not going to get what the other side is equal to. Okay? So that's why we only work on one side. Then we want to work on the most complicated side and make it to the simpler side. Adding and subtracting is generally more complicated than multiplications. Remember yesterday when we had problems where we were adding two fractions or adding trig expressions, those are the more complicated sides because it made us do more work. Some other tips: multiply out or expand if you can, factor if you can. If you have fractions over a single term, you might want to split it into several other fractions. Complex fractions, we're going to be seeing those a lot because sine and cosine can be written as 1 over secant or 1 over cosecant, and tangent is sine over cosine, and that. So we're going to be seeing complex fractions. When you are unsure of what to do, convert things to sine and cosines. That might be easier to do. Always try something. Okay? You may not see a strategy right away on what you should do, so just try something. Change stuff to sine and cosines. Add fractions. The point of these exercises isn't necessarily the actual math that we're doing. It's the problem solving and the grit that you learn from doing these, where you may spend 2 minutes on the problem and realize it's not going well and erase everything and start over. When you go on to calculus, you are going to need, not necessarily all these identities, but you're going to need that grit and that perseverance that you learn from doing these. So let's look at some. So, of course, we'll start with some of the more simpler ones, simpler looking ones, and then go to something more complicated. So we have the cotangent over cosecant equals cosine. So the left side is more complicated because we have a fraction and we have two things. And we know we want this to equal cosine. Well, if that's the case, let's change everything to sine and cosines. So the cotangent is cosine theta over sine of theta. And then over cosecant is 1 over sine theta. Okay, well now we can multiply by the reciprocal. So if we multiply by the reciprocal, we get cosine theta over sine theta times sine theta over 1. The sines will cancel, and we're left with cosine over 1, or cosine, which is exactly what we have up here, down there. So we have proven the identity. We're not trying to figure out what theta is. We're just working on, in this case, the left side until it equals what we have on the right side. All right, now letter B, we have addition on the left side and subtraction on the right side. The addition tends to be more complicated. And I see that we're trying to get secant and cosecant, which is 1 over cosine and 1 over sine. So I'm going to change tangent into sine x over cosine x plus cosine x over sine x. And to add these fractions, we have to multiply the top and bottom by the denominator of the other fraction. So this will give us sine squared x plus cosine squared x over sine x cosine x. Well, according to our identity sheet, this right here, sine squared plus cosine squared is equal to 1. So this is 1 over sine x cosine x. Well, we know that 1 over sine is cosecant and 1 over cosine is secant. So we can rewrite this, instead of 1 over sine times cosine, we can rewrite this as secant x times cosecant x. Because 1 over cosine gives you secant, and 1 over sine gives you cosecant. And because we're multiplying, the order doesn't matter. So that gives us the right side up here. Whoops. That gives us this down here. So we verified the identity. All right, let's look at the next page. Now this one we have addition and subtraction on both sides, but on the left side we have 3 terms and a fraction. So that's going to be the more complicated side. So what I'm going to do is I'm going to break this up into 3 fractions. So like in the previous problem, what we did was we got common denominators and we combined the fractions. Here what we're going to do is we're going to go backwards and break it up into 3 fractions with that common denominator. Well, at the beginning, the first one, cosine to the third over cosine, is going to give us cosine squared theta minus cosine over cosine is 1 plus sine over cosine. Well, what should we do with that? I'm going to change that to tangent. And the reason I'm going to change that to tangent is because my final answer, what I'm trying to get to, has a tangent in it. So now we have cosine squared minus 1 is equal to, cosine squared minus 1 plus tangent. So what I'm going to do is I need to change this. According to our sheet, cosine squared is equal to 1 minus sine squared. So 1 minus sine squared theta minus 1 plus tangent theta. Well, positive 1 minus 1 is 0. So I have negative sine squared theta plus tangent theta. And we're almost there. Because we are adding, we can switch the order. So we can switch this to tangent squared minus sine squared theta, which is what we had up above. And that gives us the correct answer. Now, this is not the only way you could solve this one, and that's part of the problem with this lesson, is that there's more than one way to solve these. So I could have factored out a cosine at the very beginning from everything in the numerator and canceled with the cosine of the denominator, and then that would have gotten us, this step quicker. But I think that's a little complicated to see, so I just decided to do it this way. We're going to skip letter D. Now letter E, tangent squared times cosine squared plus cotangent squared times sine squared equals 1. Well, the more complicated side is going to be the left side, and it's going to equal 1. So whenever I see that something equals 1, I go back to sine squared plus cosine squared equals 1. So that's what I'm going to try to get on the left. And I almost have that, but I got these pesky tangent squared and cotangent squared. So I'm going to change tangent squared to sine squared x over cosine squared x times cosine squared x, plus cotangent is going to be cosine squared x over sine squared x times sine squared x. We can cancel off these cosines, and we're left with sine squared x. We can then cancel off these sines, and we're left with plus cosine squared x. Well, like I was saying earlier, we know that sine squared plus cosine squared is equal to 1, which is what we were trying to get up here. So we verified the identity. Now down here, the left side is more complicated because there's more terms and we have a subtraction sign. What I'm going to do is I notice that I have a secant out front in both parentheses and a secant on the inside. So just to make it easier to see what I'm going to do, I'm going to distribute, oops, that'll be the fifth power, secant to the fifth power times tangent x. So they all have a secant, they all have a tangent in common, both terms, and both terms also have secant to the fifth power. So I'm going to factor out now a secant to the fifth power times tangent x. So I'm going to be left with, for the first term, secant squared x. And the second term, right, if I factor out secant to the fifth tangent x, all I'm going to be left with for the second term is 1. And there's a subtraction sign between them. So I factored out the secant to the fifth times tangent x, and I'm left with secant squared x minus 1. And like I said before, if you are unsure about factoring out a GCF, multiply it back in and see if you get what we started with. According to our identity sheet, this right here, secant squared minus 1 is equal to tangent squared. So now we have secant to the fifth x times tangent x times tangent squared x. And you see what we're trying to do is we're trying to get secant to the fifth times tangent to the third. Well, I already have my secant to the fifth all the way up in this step. So I converted this into tangent squared. So now that I am able to multiply these, tangent times tangent squared will be tangent to the third, which is exactly what we are trying to get. So we have proven this identity. Right, now on the next page, letter G gets complicated because we have that weird fraction and we have negative angles, but it equals secant of theta, of the positive angle. So since we have negative angles, we're going to use those even and odd identities from our sheet. So instead of 1 plus cosecant, if I look at my identity sheet, cosecant of negative x or negative theta is minus or negative cosecant of positive theta over cosine of negative theta, according to our sheet, is cosine of positive theta, and cotangent of negative theta is negative cotangent of positive theta. So I'm going to switch this just to minus. Okay, so now we have 1 minus cosecant over cosine minus cotangent theta equals secant theta. So we need to simplify this a little bit more. And one of the ways that I'm going to do that is I'm going to change cosecant and cotangent into their respective functions. So 1 minus 1 over sine theta over cosine theta minus cosine theta over sine theta. So now what I'm going to do with this, this is over 1, this is over 1, is I'm going to multiply, I'm going to get common denominators by multiplying this first fraction by sine over sine, and then this one by sine over sine. So this is going to give me sine of theta minus 1 over sine theta over cosine theta times sine theta minus cosine theta over sine theta. So then we can multiply by the reciprocal. And it looks like I may run out of room, so I'm going to go over here. So sine theta minus 1 over sine theta times sine theta over cosine theta times sine theta minus cosine theta. Well, the sines can cancel off, and I'm also going to factor out a cosine from the denominator. So then I'm going to have sine theta minus 1 over, when we factor out a cosine, we get cosine theta times sine theta minus 1. I can cancel sine theta minus 1 from the top and bottom, and we get 1 over cosine theta, which we know is equal to secant theta, and that's what we're trying to get up here. So that would be one way to prove this. Now, one of the difficult things about these identities, about this lesson, is that with me doing it, I already know where we're going to go. When you try these problems, you're looking at it for the first time, and it's probably going to take you significantly longer than it's taking me, because I've seen these before, and I've seen enough of them throughout my life where I can look at that and say, oh, I can see how this is going to evolve to that one. Like over here for letter H, I see this right here, and I say, oh, I know that I need to change that using the cofunctions identity. You're not at that place just yet because you haven't been doing these for years and years. But that's what we're going to try to get towards, is that, what do you see and how can we get there? So like I was saying with letter H, I have this cotangent of pi minus y. Remember the cofunctions identities, cofunction. And that sheet says that the cotangent of pi over 2 minus y, or any angle, is equal to tangent. So secant squared y minus tangent squared y. So this is equal to that. Now, secant squared y minus tangent y, we need to convert one of those. And it doesn't matter which one. I'm looking at my green sheet, and it says that secant squared is equal to tangent squared plus 1. Some of the other ones have minus 1, and I don't want to use that one because I want to equal to negative 1. So we can switch secant to tangent squared y plus 1 minus the tangent squared there already. So these will cancel, and we're left with 1, which is what we're trying to get. So like I said, because I've done these before, maybe not this specific problem, but identity problems, I have an idea of where we're going. All right, letter I. Right, this one, the left side is more complicated, and I noticed that I need to get secant squared. And secant squared is already right here. I know that cosecant is 1 over sine. So what I'm going to do is distribute this in, but when I do that, I'm going to write cosecant is 1 over sine x plus sine squared x times 1 over cosine squared x. Okay, the signs here are going to cancel. So I have 1 plus, and I can combine these into sine squared x over cosine squared x. Well, sine squared x plus over cosine squared x, that's going to be tangent squared x. And you might say, well, why didn't I just leave this alone instead of changing it? Well, if I left it alone, then there would be no way to combine it with that sine squared to make things simpler. So 1 plus tangent squared, according to my sheet, is equal to secant squared, which is what we were trying to get. So I verified that identity. This last one here, we have sine x plus cosine x squared. So remember, we can't distribute that square, plus sine x minus cosine x squared equals 2. Again, we can't distribute that square. But what we can do is use our special factoring patterns. Okay, so remember sine a plus b squared, we're going to use that pattern, and a minus b squared, we're going to use that pattern. So this is going to be sine squared x plus 2 sine x cosine x plus cosine squared x. That's what this is equal to. Then for the other one, so plus sine squared x minus 2 sine x cosine x plus cosine squared x. That's what this is equal to. Well, if we combine our like terms, we have positive 2 sine x cosine x, negative 2 sine x cosine x. Those will cancel. So then we have sine squared x plus cosine squared x, plus, then in yellow, the highlighted yellow part, we have another sine squared x plus cosine squared x. We know that this is equal to 1. This is equal to 1. 1 plus 1 is 2, which is what we were trying to get. Okay. So like I was saying, the more that you do these, the better you will get, the more easier it will be for you to recognize and think ahead of where we're going. But I want to emphasize that at the beginning, you are going to get stuck and you are going to get frustrated. You just have to be okay with erasing, starting over, and persevering through this. That's what this stuff is all about. It's all about how much can you persevere when you are faced with a challenge. So thanks for watching the video. Make sure to like it and subscribe.